Math 20-2 class for Monday, March 9th. We are looking at completing the sine law example that I didn't get into class yesterday. We're going to introduce the cosine law. I'm going to do an example with that, then we're going to rearrange it and do a few more examples. So let's get started. Finishing up the sine law. Here's an example. We're going to draw it as it says as shown in the question, but I'm going to draw it. The captain of a small boat is delivering supplies to 2 lighthouses as shown. So as shown, let's see what his compass directions are. It indicates that the lighthouse to his left is located north 30 degrees west. And the lighthouse to his right is located north 50 degrees east. So we're going to think of the lighthouse right here. We've got, if this is our cardinal directions, this is north. We've got south way down here, east, and west. So lighthouse A is to his left, and this reads north 30 degrees west. That means from the north, we're shifting 30 degrees to the west. And so our lighthouse is over here. Lighthouse A is over there somewhere. We're not sure exactly where, but over here, lighthouse A. Lighthouse B is north 50 degrees east. So again, that's from the north, rotating 50 degrees, but this time it's to the east. And so lighthouse B is off in this direction. Let's connect these 2 lighthouses up so that we can see our triangle, and we can see that this whole angle here is 80 degrees. And if we think about it, we know that north, south, this angle here is 90. And that makes, because we've got 50 above, this is 40 down here, just so we can see it. And it's important to keep recognizing that we have right angle triangles everywhere we go. So if I drop this line down, I have 40 there, then this piece has to be 50 right in here. Okay, just to get a lay of the land. And right in here, this angle here is 40 degrees. Thinking about having 2 parallel lines and a transversal. We've got 40 here, or sorry, 50 here, and that would put 50 down here. We horizontal across, that gives us 40, just like we have here. There's 40. Okay, and so you're going to need to be able to visualize these. Let's put in our distances now. We know that 9 kilometers from the lighthouse to his left, so 9 kilometers here, and the lighthouses are 12 kilometers apart. We're going to use the sine law because we have 80 degrees and we have the side opposite. So 80, the sine of 80 degrees divided by the side opposite, which is 12 kilometers. And we have here 9 kilometers against angle B. So we have sine B over 9. We calculate the sine of angle B by multiplying both sides by 9. Pull up the calculator. Oops, let's clear this off. We have 9 times the sine of 80 degrees divided by 12. And that gives us 0.7386 So I'll write that down. 0.7386 is equal to the sine of B. We want to calculate our whole piece, the angle. So to do that, we need to get the inverse sine of both sides. And when we take the inverse sine of sine B, that gives us the angle B. And on our calculator, we'll just find the inverse sine of that answer, that previous answer. We press enter, and that we'll round that to 48 degrees. Excellent. So this whole big angle is 48 degrees. And I'm just going to use red here. So this is west going north, right? So if below here is 40, then this piece here has to be 8 degrees. Right, so we've got a line coming off like this. Oops. So this angle is 8 degrees. Everything's taken from the north, so this is 90 minus 8, which gives us 82 degrees. So the angle from the north is 82 degrees. So what must he follow when he leaves B to go to lighthouse A? He's going to have to go from north 82 degrees to the west. That will be his angle. You'll want to spend a bit of time with those directions because they're challenging, these direction questions. I'm going to go on now to the cosine law. So here's our cosine. It's in any acute angle. We have, if we're looking for side A, we take A squared, that's here, A squared, is equal to B squared plus C squared minus 2BC times the cos of angle A. So notice if I am looking for side A, I deal with A here, and the angle opposite is what's over here. The other two sides fill in the other spaces. So now if it's B, I'm looking for side B, that's here, I'm going to have the angle B on that side. So it's the cosine of B. And notice in the other spots I have A and C. Again, if I'm looking for C, I'll have this cosine of angle C, the side opposite, here, the angle opposite, sorry, of the side, and then the other two sides, A and B, fill in the other locations. So we can do this for any triangle. I'm going to use P, Q, R. Oops, now that should be a capital Q. P, Q, and R. So let's have side R, side Q, and side P. Let's say that I'm looking for side Q. So if I'm looking for side Q, I'm going to start with Q squared, and that's going to equal, and the other two spots are filled with R and P, the other sides. So we have R squared plus P squared minus 2 times R times P times the cosine of angle Q. The side opposite, or the angle opposite the side we're looking for. Doesn't matter how the triangle is labeled, we can fill in our formula with this relationship. Maybe stop the video and try doing side P. So I'm going to do that, fill it in now. P squared is equal to R squared plus Q squared minus 2RQ cosine of angle P. and you might want to practice that. Let's do an example. Determine the length BC to the nearest meter. So BC is here, that's this side. I'm going to call it side A because it's opposite, across from angle A. So if it's A squared, that's equal to B squared plus C squared minus 2BC times the cosine of angle A. So notice I have side B and side C and angle A. And so I have two sides and the included angle. I don't have any angles and side opposites. And that's what leads me to know that I'm going to need the cosine law. Let's substitute in. We have 32 squared plus 40 squared minus 2 times 32 times 40 times the cosine of angle 58 degrees. Now we can calculate that, use our calculator. The beautiful thing is we can enter this in completely in one step. So 32 squared plus 40 squared minus 2 times 32 and just 32 times 40 times the cosine of 58 degrees. It's really important at this point that we don't think that that's our final answer, because that's equal to a squared. We have 1267, so a squared is equal to 1267 and some decimal points. Remember that we want to get a, not a squared. We have to square root a squared to get a, so we have to square root that 1267. So we go second and square root, second and answer the negative sign, press enter, and we come up with 35.6. So a is equal to 35.6 meters, because the other two sides are in meters. And notice it says to the nearest meter. So we're going to take this and round it to 36 meters. So CB is 36 meters. Let's look at a rearrangement of the cosine law. Now, if we draw a triangle, we have A, B, C, and let's just work with a squared. So we'll do a squared is equal to b squared plus c squared. So a, and we have c here and b here. Now the c and b, they're interchangeable. Doesn't matter the order. Minus 2 times bc times the cosine of angle A. Now, if we're given A, B, and C, if we're given the length of all of our sides and are being asked to calculate an angle, we have to rearrange this equation. So the first thing I'm going to do to rearrange it is to subtract both sides by b squared and c squared. So a squared minus b squared minus c squared. So that gives me a squared minus b squared minus c squared. And that leaves me with negative 2bc times the cosine of A. I want to get the angle portion by itself, so I'm going to divide both sides by negative 2bc. It cancels here, and we're left with the cos of A. One of the things that happens with this is that we multiply by negative 1 over negative 1, and that gets rid of the negative in our denominator. So we have 2bc, positive 2bc here on the bottom, and we end up changing the signs of everything inside. So what happens is we get, when I multiply that negative through, I have a positive b squared and a positive c squared. So I go b squared plus c squared minus a squared. So the piece that's being subtracted, the side that's subtracted and the angle opposite, those are the two that work together. So in a triangle, in this instance, I would be looking to find A. But I could just as easily be looking to find C. So the cosine of angle C is going to equal, and I just interchange those pieces. I want the c squared subtracted over here, so it's going to be a squared plus b squared, and I'm going to be divided by 2 times a times b. Again, it's a matter of the pieces that are important, the cosine and the angle opposite. The other two sides fill in the rest. Let's do an example. Oh, I'm just going to pop onto the formula sheet here. I want you to see this is your formula sheet, so the sine law is sitting on your formula sheet. It isn't written this way, but you can have A over sine A equals B over sine B equals C over sine C. So you need to, if you want to use it differently than what's sitting on the formula sheet, you just need to remember that. Here we have the cosine law when we're looking for a side, and here is the cosine law when we're given three sides and we're asked to calculate the angle. So you don't have to do that rearranging. It's here. You simply have to know how to use that equation. Let's do an example. The diagram at the right shows the plan for a roof with support beam DE. So our support beam DE is parallel to AB. The local building code requires that the angle formed at the peak of the roof is to fall within a range of 70 degrees to 80 degrees so that the ice and snow will not build up. Will this plan pass the building code? So we need to see, is this angle big enough? That's the peak. I'm looking for angle B. So it's going to be the cosine of angle B, and that's equal to side A squared plus side C squared minus side B squared. Again, angle B, side B is being subtracted, divided by 2 times A times C. Now we simply substitute in our numbers. Notice here that we have 9 feet 6 inches. Remember, 6 inches is half a foot, so we have, I said 9, it's 19.5 feet. Substitute in. A is 19.5 squared plus C, which is 20 squared. Oh, no, B is 20 squared. Careful that we substitute in correctly. Side A, or side C, is 10 squared minus 20 squared, all divided by 2 times A, which is the 19.5, times C, which is 10. It's essential when we do this rearranging that we calculate what's on top, what's on the bottom, and then divide. So I'm going to do this in 2 separate steps. I'm going to take 19.5 squared plus 10 squared minus 20 squared. So I've made a mistake here, so let me just fix that. I'm going to insert my plus sign there. Here we go. 18.2 or 80.25. So I have 80.25 over, and let's calculate our denominator. 2 times 19.5 times 10. And again, I have 9.5. So correct that. Oops. Try again. 2 times 19.5 times 10. There we go. Entered it correctly. We have 390 in our denominator. remember that this is the cosine of b equaling, and we're going to divide that out. So it's 80.25 divided by 390, and we get 0.2058. And I'll write that in. 0.2058. Okay. Now we're going to take the inverse sine. Oh, sorry. This is going to be the inverse cos, not sine. Be careful about that. The inverse cos of cos b and the inverse cos here. So angle B, and if you want to write it out, is the inverse cos of 0.20858. Pull up our calculator, and we have second cos, so the inverse cos, and we pull in our answer, second and negative, press enter, and we get 78 degrees. So angle B is equal to 78 degrees. Want to be careful that we're answering the question that was asked. So between 70 and 80 degrees, absolutely. So this design meets building code. Okay. Let's do another example. Here we have a three-pointed star. It's made up of an equilateral triangle and three consecutive isosceles triangles. And we've got the measurements from one, and you can see it's sitting right up here in there. Those shapes are what we're looking at. And again down here. And we're being asked to determine the length of each side of the equilateral triangle. Well, so we're given an angle and two sides, and we're looking for the side opposite the angle. I'll call that x. That configuration of two sides and the angle in between tells us we're going to look for our cosine law. So x squared is equal to 60 squared plus 60 squared minus 2 times 60 times 60 times the cosine of 20 degrees. Notice those two other sides, they just fill in those other spaces. And if you need to, we'll go a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And you can see how it just fits in. Let's calculate this on our calculator, and remember we're going to take the square root. So I take 60 squared plus 60 squared minus 2 times 60 times 60 times the cosine of 20 degrees. Calculate it. So we have 434. Again, remember this needs to be square rooted. So we go second and square. Oops. Let me just get out of here. Sorry. We go second and square root. So second and x squared to get the root. Second and negative to pull in our answer. And that's 20.8. So this comes out to 20.8 centimeters. So x is equal to, again, catch our rounding to the nearest centimeter. That's 21 centimeters. Let's look at the practice problems. So in your textbook, page 150 to 153, numbers 1 through 15, or if you prefer the workbook, 79 to 81, numbers 1 through 7. Have a good day, and I will talk to you tomorrow.